All right, so today we're looking at all of 9.1, making sure that you've got it. So, number 1, square root of 24. For each of these, I encourage you to try them first, pause the video, and then check and see how you did after you finish them. Okay, so I can break up the square root of 24 into the square root of 4 times the square root of 6. The square root of 4 is 2, and then I can't do anything with the square root of 6. So remember, we're breaking it apart into two numbers that multiply to give me 24. One of them has to be a perfect square. On 48, number 2 with negative square root of 48, I keep the negative out in front, and I can break that down into the square root of 16 and the square root of 3, which gives me a negative and then a 4 and a square root of 3. If you did it, breaking it down into smaller numbers, so for example, the square root of 4 times the square root of 4 times the square root of 3, you'll get a 2 times 2, which still gives you the same thing. So even if you're breaking them apart in a different manner than I am on the first step, that's okay. Remember, as long as you end up with the same end result, then you've done it an okay way. So number 3, the biggest one I can break it up to is actually the square root of 81 times the square root of 2. You could have found a smaller one. That's okay too. And then g to the 6th power is an even exponent, so I'm going to leave it like that. So the square root of 81 is 9. The square root of g to the 6th power is g to the 3rd power. Remember, taking the square root basically cuts it in half. If it's an odd number, that odd one stays back underneath. And then I keep the square root of 2. Okay, number 4. I'll keep the negative out in front. I can break this down in the square root of 64 times the square root of 4 times the square root of 2. I have the square root of h to the 6th power, h to the 6th power, and then the square root of h. Remember, if it's an odd one, leave that odd one by itself. So I'll keep the negative out in front. The square root of 64 is 8. The square root of 4 is 2. The square root of h to the 6th power is h to the 3rd power. And then I keep the square root of 2h underneath. They can go under 1 together. Just multiply those last ones together, and I'm done. All right, so now we're dealing with ones with fractions. Remember, we start by giving them each their own radical. Okay, so the square root of 25 is 5. Square root of 64 is 8. I'm done. Number 6, give them each their own radical. And this is the work that you should be showing when you're doing any of your work as well. Square root of 49 is 7, so I'll keep the negative out in front. I'll keep the square root of 6, and then I have 7 in the denominator. Remember, it's okay to have a radical in the numerator as long as it can't be broken down anymore, and square root of 6 cannot be broken down. All right, number 7, keep the negative out in front. Give them each their own square root. And these are actually both perfect squares, so I can take the square root of both of them. Number 8, I'm going to break it apart. I'm going to give them each their own square root, and I'm actually going to break it apart at the same time. So on the bottom, I have the square root of 64 and the square root of y squared. All right, so I'll start with my denominator. Square root of 64 is 8. The square root of y squared is y. In the numerator, square root of 49 is 7. The square root of x squared is x, and I still have a square root of x. That's all I can do on it. All right, the next ones are your cube roots. Remember, it's the same process, but you're trying to break it down into perfect cubes. So negative 135, I can break that part as the cube root of negative 27 times the cube root of 5. Notice I put the negative on the one that's actually the perfect cube. So I can pull that out as a negative, and then I leave a positive under my radical. Let's see, number 10, the cube root of 729. Ooh, this one's nice. It's a perfect cube. 9 times 9 times 9 is 729. All right, the next one, we'll keep the negative out in front. And then I can break this down as the cube root of negative 8 times the cube root of 8 times the cube root of 3 times the cube root of x cubed now, because that's a perfect cubed, and then I would still have a cube root of x squared. So I have the negative out in front, but then I have it times this negative 8 that's under my radical, and I pull that out as a negative 2, so it actually becomes a positive 2. So I'll actually erase that then. Okay, then I have times another 2. Then I have times an x that I'm able to pull out. And then I'm left with a cube root of 3 and an x squared. So last thing I can do is multiply my 2 times 2 together, which would be 4. I still have my x, and I still have the cube root of x squared. All right. We would do the same thing on number 12. We won't do all of these problems, though. All right, number 13. So I could go ahead and break this apart, but I'm going to show you another strategy. I can actually, since 15 over 50 can be reduced, I can divide them both by 5. I'm going to do that and make my number smaller. As long as I'm dividing both the numbers by the same thing, it's okay. So then I have the cube root of 3 over the cube root of, the square root of 3 over the square root of 100. And the square root of 100 is just 10. And then I have the square root of 3. It's not the only way I could have done it. I could have broken apart the 500 first and then simplified it at the end. But I would rather reduce at the beginning, make my number smaller to work with. Okay, so on the next one, I'll give them each their own square root. The square root of 100 is 10. 8, when I take the square root, can be broken down the square root of 4 and the square root of 2. So I end up with 2 square root of 2 over 10, which can be reduced. The 2 over 10 can be reduced to 1 over 5. All right. Let's see. Let's do one more in this section. Let's actually do number 16 because it's got a cube root. So I can break this apart into, let's see, the cube root of 4. Okay, this one I'm actually going to break it apart. I can't take the cube root of 16. It's not a perfect cube. But I could think about what would I have to multiply by so that my number underneath would be a perfect cube. 64 is a perfect cube. So if I multiply it by 4, which is the same thing as multiplying by the cube root of 4, then I'm going to get the cube root of 64, which is a number I can simplify. So then I'll multiply the top by the cube root of 4 as well. So the cube root of 64 is 4. And then on the top, I'll have 8 cube root of 4. So I chose to multiply the top and bottom by something a little unconventional. I chose a number that would give me a perfect cube. I could have multiplied by the cube root of 16 and then reduced it down. But again, we're trying to look for something that's going to make it cancel out. So if I can make it a perfect cube, that's what I want to multiply top and bottom by. And then 8 over 4 can be reduced to just 2. And then I have the cube root of 4. Again, on some of these, you may be doing different steps. As long as you end up with the same end result, you can simplify it to the same thing I simplified it to, you're okay. Okay, a couple more to do. All right, so number 17, this is the one where we're going to have to multiply by the conjugate. So I'm going to be multiplying top and bottom by -3 plus 3 square root of 3. Remember, you have to multiply top and bottom by the same thing. And remember, the conjugate is the same thing as this, but instead of subtraction, we would make it addition. And now I use the distributive property. So I'm going to do 5 times -3 on the top, and then plus, and then 5 times 3 square root of 3, which would be 15 square root of 3. Over, and on the bottom, remember, there's going to be 4 things of multiplying. We're doing FOIL. -3 times -3 is 9. -3 times a -3 square root of 3, is a positive 9 square root of 3. And then if I do the 3 square root of 3 times the -3, that's a -9 square root of 3. And good for us, those are going to cancel out, right? And then minus 3 square root of 3 times 3 square root of 3 is 9 square root of 9. So the square root of 9 is 3. So I have a -9 times 3, which is a -27. And I have the 9 minus that, which means I have a -18 in the bottom. And in the top, I have a -15 plus 15 square root of 3. I am okay with you leaving it like that. However, this one can be reduced more. If you're going to reduce and you've got 2 things on the top, you have to be able to divide this, this, and this. All 3 things have to be divided by the same thing. So I'll show you how to reduce that one. So each of those 3 things can be divided by 3. So that would make that a -5 plus 5 square root of 3 over, and when I divide the -18 by 3, that gives me a -6. And that's the most I could do for that one. All right, let's do one more with the conjugate. So let's do number 18. So I'm going to multiply both the top and the bottom by 4 minus 4 square root of 5. 4 minus 4 square root of 5. So multiplying top and bottom by the conjugate. When I do that, I get 12 minus 12 square root of 5 over 16 minus 16 square root of 5 plus 16 square root of 5, and then minus 16 square root of 25. All right, so these two cancel each other out. This becomes a 5, so I have negative 16 times 5, which is a negative 80. So in the denominator, I have 16 minus 80, which is a negative 64. And in the top, I have 12 minus 12 square root of 5. I can reduce all three parts. This part, and this part can all be divided by 4. So when I divide by 4, I'll end up with 3 minus 3 square root of 5 over, and when I divide 64 by 4, I get a negative 16.